our topic is a half reactions, and half reactions are ones that involve electrons being lost or gained. Here's our objective, and this may seem like a lot of gobbledygook, but we can definitely do it. Another way to think of it is when you look at a reaction, how do the pieces make the whole? All right, how do they come together in terms of the electrons? We're going to go over a couple definitions. So here's oxidation or reduction, redox, when the electrons are being transferred between species. So I've got two atoms. One becomes positive, that is oxidation because it's losing electron. The other one, therefore, is going to become negative and is going to be going through reduction because it's gaining electrons. Now, another important thing to know: oxidizing agent. This, in a way, seems kind of counterintuitive, but it's the one that is causing the oxidation of something else, and in itself, it becomes reduced. So here is my oxidizing agent because it's causing the oxidization of this other species, whereas the reduction agent is causing the oxidization of something else. Or not the reduction agent is causing the reduction. So it's going to be what is reduced. I said that wrong again. The reduction agent gets oxidized because it causes the reduction of something else. There we go. All right. Here's a mnemonic to help you remember which one's which. Leo the Lion says Gur. Well, Leo the Lion says Gur is losing electrons is oxidation, and gaining electrons is reduction. All right? Here are the steps to do it. First, you got to know what's going on, what's gaining, what's losing. You're going to write your half equations. Those are with the electrons. Remember, least common multiple. You can't lose or gain electrons. All right? Then you're going to add them up, and that's going to be our net ionic. Here's my source, and I use this to get a lot of my problems. Okay, here is my equation. I want to know the net ionic. First thing I need to do, identify what's losing and gaining electrons, oxidized and reduced. So aluminum is going here to here. You can see it's 0 to +3. This would be +2 to 0. Therefore, what's being oxidized, what's being reduced? So Leo the Lion, Leo losing electrons, oxidation. What's losing electrons? Aluminum is. Says Gur, what's gaining electrons, reduction? The copper is gaining. All right. Now I need to write my half equations. So to write the half equations, I need to keep track of how many things they're losing. So now aluminum is losing 3, so the 3 electrons that it loses go on the product side. It looks like that. And that these are not 5s, it's an S. And since it's being reduced, those electrons go on the reactant side because they're being gained. All right. Now the next thing is to balance my electrons. And by balance, you need to, like, the amount gained or lost has to be the same. So 2 and 3. I've got an extra one. What's the least common multiple between 2 and 3? It's 6. So I'm going to multiply this by 2 and this by 3. So 3, this becomes 6, 3, 2, 2, 6. All right. Now I've got equal amounts of electrons being gained and lost, or lost and gained. And then I would add this up. All right. And I'm going to get this. Now you'll see I've already crossed out because I had done this. I made a mistake with the video. But my electrons add up and they get lost. And there. And now my net ionic equation is going to be what everything is, like that. All right. Here's another example. All right. Now, if you look at this, we should be able to figure out the ionic equation in our minds. Potassium is going from 0 to +1. Zinc is going from +2 to 0. Therefore, zinc's gaining 2, two potassiums are gaining 1 each. All right? So my net ionic equation is going to look like this. All right? But let's go through it and see how we get there. What's being reduced, so this is going from 0 to +1, +2 to 0. All right? What's losing? Losing electrons, oxidation. Potassium is losing. Zinc is gaining. So potassium is being oxidized. Zinc is being reduced. What are my half equations? All right. Here is zinc because it's gaining 2. Here is the potassium. And I put these 2's in already because the half equation is actually the one without the 2. There wouldn't be 2's there, right? All right. I added that so they would balance out. And then that adds up to this. What falls out? The electrons fall out because they're on both sides. And that's my net ionic equation. All right. These are solids, and that's aqueous. All right. And that's how you do it. Hope that helped.